Now in session 111, we're going to take a little bit deeper look at arithmetic sequences. These were introduced in the previous lesson, the previous session. First of all, we have a formula here. I've gone ahead and I've started off with an arithmetic sequence down here at the bottom, 4, 8, 12, 16, 20, all the way up to the number 400. That's my sequence. It actually stops at 400. If it continued on indefinitely beyond 400, there would be 3 more dots over here. All those 3 dots mean here now is that we have not written all of the terms between the 20 and the 400, but there are many there anyway. They're just not visible or written. In this formula up here, S stands for the sum. If the question were asked, what is the sum of the first 5 terms in this arithmetic sequence, this formula would be how we would determine that. N represents the number of terms that we're trying to determine this sum for. So N here would be 5. So the sum of the first 5 terms would be equal to T1. Well, T1 is your first term, plus Tn. N would be your 5th term here because we're substituting a 5 for N. And we would calculate it out that way. So let's go ahead and fill it in. S5, in other words, the sum of our first 5 terms in this arithmetic sequence is going to equal T1. Well, what's T1? T1 is 4. And what we're going to add to it is T to the N. Well, what's the N in this example? It's 5. So what is our 5th term? Well, that would be 1, 2, 3, 4. That would be number 20. 20 is our 5th term. And then we're going to take that and multiply it by our number of terms. How many terms are there that we're adding? 5. And then we're going to take that and divide it by 2. Now your textbook goes over a very lengthy explanation as to how this formula was come up with. That would be much too time consuming and cumbersome to go over here, so I'm just bypassing the proof for it or how it was developed. It's just enough to know that this is the formula. However, for those of you that can sort of visualize this a little bit, what we're really doing here is we're taking the first term and we're taking our last term, we're adding them together and then dividing by 2, which is very similar to finding the average of them. Because we are adding the same number to each term here, we can take the first term, add it to the last one, divide it by 2, and because of the order of that, we can divide that by 2 and come up with an average. And then we take that average and we multiply it by the number of terms that we're adding together. So S to the 5th is going to equal 4 plus 20 times 5 over 2. Well, let's do it. Remember, our commutative property says it does not matter what order we multiply in. If everything that we're having is being multiplied, we can multiply in any order. Well, remember, dividing by 2 is the same thing as multiplying by 1/2. So what we really have here is 4 plus 20 collectively, parentheses, times 5 times 1/2. So let's do our 4 plus 20. 4 plus 20 is 24. Well, what's 24 times 1/2? 12. And then 12 times 5 is 60. The sum of our first 5 terms in this arithmetic sequence will be 60. Well, let's go down and double check. What's 4 plus 8? 12. 12 plus 12? 24. 24 plus 16? 40. 40 plus 20 is 60. And that's what we calculated over here. Now, I've gone ahead and said that this particular sequence terminates or stops at the number 400. And the question here is, can you determine what the sum will be of this sequence that starts with 4 and ends with 400? Well, once again, we need to use our formula here. Sn equals T1 plus Tn times n over 2. But what we don't really know yet is what's the value of n? How many terms are there in this? Well, let's see if we can make some conclusions to actually figure it out. First thing is, what are we doing? What are we adding? Since this is an arithmetic sequence, we are adding the same number to each term to produce the next one. What did we add to the 4 to get to the 8? Well, we added 4. So we add the same 4 to the 8 to get to 12, add 4 again to get 16, 4 again to get 20, and so on. So what we know that we're doing is we're adding 4 to each term. Well, let's take a look a little bit deeper. Our first term is 4. Our second term is 8. Our third term is 12. Another way that you can kind of think of this is, what did we, for our first term here, 4 times what equals 4? Well, 4 times 1 is 4. Well, we're adding another 4 to get 8. And remember, multiplication is just repeated addition. So if we are going 4 plus 4, that's really the same thing as 4 times 2. So if our first term here is 4 times 1, our second term here would be 4 times 2. Our third term, since we're adding another 4, would be 4 times 3. Our fourth term would be 4 times 4. Our fifth term would be 4 times 5. What's our last one? At this point, all we know is that it's an n. But what would that be? 4 times what would be 400? Well, 4 times 100 would be. So actually, we were able to determine here by just using a little, some strategies. We were actually able to determine that the 400 is the 100th term. Now we can do our formula. The sum of the first 100 terms is going to equal our first term, t1, which is 4, plus our last term, t to the n, which would be 400, times 100 divided by 2. And remember, dividing by 2 is the same thing as multiplying by a half, so we are going to use our commutative property here and reorder our multiplication. First thing we have to do is what's inside the parentheses. 4 plus 400 is 404. Well, what's 404 times 1/2? Well, that would be 202. And then 202 times the 100 that's left would be 20,200. So the sum of the first 100 terms in this arithmetic sequence is 20,200. Here, we're going to use the same arithmetic sequence, 4, 8, 12, 16, and so on. But here, instead of trying to find the sum of all of the terms up to a certain point, or finding the sum of the nth or n terms, what we're trying to do here is to determine what is the nth term of this sequence. For example, what if I asked you, what's the 500th term of this sequence? Or what is the 17th term? Or what is the 9th term? Or what is the 26th term? This formula here tells us how we determine that. Your nth term is going to be determined by taking your first term and adding to it n minus 1 times d. Well, what does d represent? D is the number that you're having to add to each term to produce the next. Well, in our sequence here, we're having to add 4 to each term. So d would equal 4. N minus 1 is going to tell us, well, if we're after a particular nth term, we subtract 1 from that, multiply that by d, and add it to what we started with. Before we actually plug in some larger n terms, let's see if we can detect really what's going on here by using a small number of terms. Let's say I were to ask you, what is the sum of the first 2 terms? Well, we could do that easily and just blow off the formula. We could just take a look. 4 and 8, well, 4 plus 8 is 12. But let's see how we can determine that same answer by using the formula. Let's take a look at our first term. And we're going to add to it our second term. Or we're going to try to determine, I should say, what the second term is. Well, if we come up here, t1 is 4. And the number of terms that we're after is 2. So if I put a 2 in here for n and subtract that from that 1, I get 1 left over. And then I'm taking that 1 and I'm multiplying it by the number that we have to add to produce each term. Well, what number do we have to add to produce each term? We have to add a 4. So 4 times 1 would be 4. We take that and we then add it to the number that we started with, which was a 4. Let's take a look at our first 3 terms. Forget it for a moment that you know that they're 8 and 12. If I just asked you, what is the third term? Well, we start off, our first term would be a 4. And what we're going to add to it is, well, we know we are after 3 terms. What we're going to do is 3 minus 1 is 2, plus 2 times, what did we have to add to each term? 4. So to find our third term, what we have to do is take our first term and then add to it 2 more terms that are being multiplied, that are being added by 4 to produce it. And since 4 plus 4 is the same thing as 2 by 4, we rewrite it that way. What if I asked you, what is my fourth term? Using our formula, our first term is 4. What do we have to add to the 4 to determine what our fourth term is? Well, we have to add 4 minus 1. Well, that's going to be 3. And then what did we have to add to each term to produce the next one? We had to add a 4. So we start off with our first term, which is 4, and then what we have to add to it is 3 times 4. 3 times 4 is 12. 12 plus 4 is 16. Our fourth term is 16. Now the question is, what is my 17th term? Well, we can just use our formula. Our 17th term of this arithmetic sequence is going to be equal to our first term, t1, which is 4. There's our first term. And then what we're going to add to that, we're after our 17th term, but our formula says take that n and subtract 1. That'll be 16. And then we have to multiply it by d. Remember, d is what we had to add to the term to produce the next one. d is 4. So our 17th term is going to be equal to 4 plus 16 times 4. 16 times 4 is 64. 64 plus 4 is 68. Our 17th term is 68. We'll do just one more and then we'll move on to our review. The question here is, what is our 83rd term in this arithmetic sequence? Using our formula, t1 represents our first term. Our first term is 4. What we're going to add to that is going to be n minus 1. Well, n is 83. 83 minus 1 is 82. And that 82 is being multiplied by d. d is the amount that we had to add to each term to produce the next. d is 4. 4 times 82 is 328. 328 plus 4 is 332. Our 83rd term in this arithmetic sequence is 332. As a review, here are the 2 different formulas we went over. The sum of the first n terms in an arithmetic sequence is determined by the following formula. Sn, S standing for the sum of the first n terms in a particular sequence is going to be equal to the first term plus the last term, in parentheses, multiplied by the number of terms divided by 2. And then lastly, to determine what the nth term is in an arithmetic sequence, we use the following formula. Tn means the nth term is equal to your first term plus the number of terms minus 1 multiplied by d. And d represents the number that you had to add to each term to produce the next term in your arithmetic sequence. That'll finish up then session 111 on arithmetic sequences.